Module 2 Fundamentals of Logic. A proposition is a sentence which is either true or false. A proposition is denoted by using letters P, Q, R, etc. A proposition is simply a statement which is a declarative sentence with some definite meaning. A proposition is either true or false. The truth value of a proposition is denoted by T or F or by using 1 and 0. It is never both, neither, or somewhere in between. Examples: P be the proposition, it is raining. Q denote a proposition, Combinatorics is a required course for sophomores. R is another proposition, Beijing is the capital of China. Q is a proposition, 2 plus 3 equal to 5. Now consider the proposition, who is there? So it is not a declarative sentence, it is only a question, so it is not a proposition. La 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 la, it is meaningless, so it is not a proposition. Just do it, it is only a command, so there is no truth value associated with this, therefore this is not a proposition. 1 plus 2, so this is not a proposition. Negation. The negation of a proposition P is the statement obtained by negating statement P. The truth values of P and the negation of P are opposite. So this is the symbol for a negation and is read as not P. For example, consider the proposition P, A is a consonant. Then its negation of P is, it is the case that A is not a consonant. R is another proposition, the Hudson is a big river. Its negation R is, the Hudson is not a big river. A compound proposition is built from propositions by the use of the connectives and, or, and not. Suppose we have two statements or propositions denoted by P and Q respectively. Then using the three connectives we get another proposition known as a conjunction. So P and Q is the conjunction of two propositions P and Q. So definition: conjunction. Let P and Q be statements. The conjunction of P and Q, written as P and Q, which is read as P and Q, is a statement formed by joining statements P and Q using the word and. The statement P and Q is true if both P and Q are true. Otherwise, the compound statement P and Q is false. For example, consider two propositions P and Q, where P is the proposition, Combinatorics is a required course for sophomores. Q is the proposition, Margaret Mitchell wrote Gone with the Wind. So the compound proposition obtained by using the conjunction is a proposition P and Q and is read, Combinatorics is a required course for sophomores, and Margaret Mitchell wrote Gone with the Wind. Another logical connective is known as disjunction. Let P and Q be statements. The disjunction of P and Q, written P disjunction Q, is the statement formed by joining the statements P and Q using the word or. The statement P disjunction Q is true if at least one of the statements P and Q is true. Otherwise, P disjunction Q is false. The symbol is read or. For example, consider two propositions P and Q where P denote the proposition combinatorics is a required course for sophomores, and Q is a proposition Margaret Mitchell wrote gone with the wind. So the compound statement obtained by using the disjunction is P or Q combinatorics is a required course for sophomores, or Margaret Mitchell wrote gone with the wind. Another compound proposition is implication. So let P and Q be propositions. The proposition if P then Q is called an implication or conditional proposition. The implication if P then Q is written P implies Q. So P implies Q is read if P then Q, or P is sufficient for Q, or Q if P, or Q whenever P. For example, consider two propositions P and Q where P denotes proposition combinatorics is a required course for sophomores, and Q is a proposition Margaret Mitchell wrote gone with the wind. So the compound proposition obtained by using logical connective implication operation is P implies Q and is read if combinatorics is a required course for sophomores, then Margaret Mitchell wrote gone with the wind. The statement P is called a hypothesis and Q is called conclusion in the conditional proposition P implies. So another logical connective is by implication. Let P and Q be statements. The statement P if and only if Q is called the by implication or biconditional proposition. Biconditional P if and only if Q is written as P implies and implied by Q. P implies and implied by Q is read as P if and only if Q, or as P is necessary and sufficient for Q, or as Q if and only if P, or Q when and only when P. For example, consider two propositions P and Q where P is a proposition combinatorics is a required course for sophomores, and Q is a proposition Margaret Mitchell wrote gone with the wind. So the compound statement P if and only if Q is read as combinatorics is a required course for sophomores if and only if Margaret Mitchell wrote gone with the wind. Truth table. If we consider a compound proposition, say for example P and Q, then what is the truth value of such a compound proposition? So in order to get the truth value of compound proposition P and Q, we need to consider truth values of simple statements P and Q. The precise effect or truth values for the connectives can be summarized in the table known as a truth table. A truth table is a tabular listing of all possible input value combinations for a logical function and their corresponding output values. Similarly, the truth table of a logical proposition is the truth table of the corresponding logical function. For any input variables, there will always be 2 raised in rows in the truth table. Truth table of disjunction. or logical connective or. So consider propositions P and Q and the compound statement P or Q. So when we consider proposition P, it assumes 4 different truth values. So corresponding to the occurrence of another proposition Q, we can consider the truth values of P and Q as T, 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 F, F, T, F, F. That is, there are 4 different possibilities associated with 2 given proposition P and Q. Whenever P and Q are 2 propositions, P is true, Q is true, then a compound proposition P or Q is true. Similarly, when P is true, Q is false, then the compound proposition P or Q is true. When P is true and Q is false, this compound proposition P or Q is true. Similarly, when P is false, Q is true, the compound proposition P or Q is true. And the 4th case is when P is false, Q is false, the compound proposition P or Q is false. So here the compound proposition P or Q is a false proposition, or its truth value is F or 0 only when both propositions P and Q assume a truth value F. Similarly, consider the truth table of conjunction. For given proposition P and Q, we have 4 different cases: TT, TF, FT, FF. And the proposition P and Q is true only when both proposition P and Q assumes the truth value T. For all other 3 cases, the conjunction P and Q is false. Now, the third logical connective is implication, and when we consider P false, Q true, then P implies Q is true, P true, Q false, P implies Q is false. So P implies Q is false in only one case, that is when P true, Q false, P implies Q is false. Now consider the by implication or by conditional proposition. So by conditional proposition P if and only if Q is true only when both proposition P and Q assume same truth values. So P true, Q true, P if and only if Q is true, P false, Q false, P if and only if Q is true. For all other 2 cases, P if and only if Q assumes the truth value F. Now consider example. Let STU denote the propositions. S is the proposition Phyllis goes out for a walk. T denotes the proposition the moon is out. U is the proposition it is snowing. Now, using logical connectives, we can consider the compound propositions T and negation U implies S. Another proposition is T implies negation U implies S. So if you consider T and negation U implies S, then we can make English sentence corresponding to this given compound proposition. So the sentence is, if the moon is out and it is not snowing, then Phyllis goes out for a walk. Similarly, for the second given proposition, T is the moon is out. So if the moon is out, then if it is not snowing, Phyllis goes out for a walk. Another example, Phyllis goes out for a walk if and only if the moon is out. So we need to convert this into a proposition, a compound proposition. So here we have if and only if. So the compound proposition is yes, if and only if T. Another example, if it is snowing and the moon is not out, then Phyllis will not go out for a walk. So the corresponding compound statement is U and negation T implies negation S. It is snowing, but Phyllis will still goes out for a walk. So the compound proposition is U and S. Next definition, tautology and contradiction. A compound statement is called a tautology if it is true for all truth value assignments for its component statements. If a compound statement is false for all such assignments, then it is called a contradiction. So, a tautology is a proposition which is always true. For example, consider the compound proposition P or negation P. So, in the truth table corresponding to P or negation P, you can see that truth values are T. So, it is a tautology. A contradiction is a proposition which is always false. For example, if you consider P and negation P, in the truth table, we can see that P and negation P assumes value F. So, it is a contradiction. So, tautology is denoted by T naught and contradiction is denoted by F naught.